Good morning, everyone, and thank you for joining the H.C. Wainwright 2022 Global Investment Hybrid Conference. My name is Matt Moretta, and I'm an H.C. Wainwright investment banking analyst. While we are hybrid this year, we're confident we're able to provide value to you with over 550 companies presenting at this conference, including multiple sectors like life sciences, cryptocurrency, blockchain, fintech, TMT growth, and clean tech. H.C. Wainwright is a full-service investment bank dedicated to providing corporate finance, strategic advisory, and related services to both public and private companies across multiple sectors and regions. For more information, please visit us at hcwco.com. With that said, I'd like to introduce our presenter. I'd like to introduce Nelson Lee, COO of FuelPositive. Nelson, if you'd like to take it away.
Great, thanks so much. We're starting out with our standard document, the disclaimer. I don't expect everyone to read that, but you can understand that we're under a standard disclaimer. That's also available on the website. So thanks for your time that you're giving us today. As a brief introduction, I am the COO of FuelPositive. I am been in the business in industrial businesses, mainly automation, for about 25 years. My main job is to commercialize these systems, develop future technologies, and get them to market and build out our facilities. We have started with our first one in Waterloo, Ontario, and that's where we're based. We are a company dedicated to acquiring and commercializing the clean, sustainable, and economically viable environmental solutions that can be deployed in the short term, not decades from now. Our initial technology is a containerized system for producing green ammonia. Right now, we are in the demonstration phase, building our first units to be placed in the field later this year. Our system is designed to produce green ammonia on site for a wide variety of uses. The first demonstration system will be fully validated before it goes into the field. We have a specific program for validating our technology. Every validation is performed following a standard gauge repeatability and reproducibility process. It involves 3 different tests performed by 3 different sources. Sources are FuelPositive, an institution such as a university, and it'll be accredited. This process is what our investors and customers expect, so they know they can trust any claims that we're making. That's just an example of who FuelPositive is. An example of some of those tests are the purity of the hydrogen, purity of the nitrogen, and then purity of the ammonia, as well as all the rates and the energy consumptions going into the system. What is ammonia and what is the significance of our technology? Also called NH3, ammonia is one of the most produced chemicals on the planet, with 200 million tons consumed annually. In fact, it is considered to be one of the 4 building blocks of modern society, along with steel, cement, and plastics. Most people hardly ever think about ammonia. In fact, most people aren't even aware of it. But if you ask a farmer, they know. 80% of ammonia manufactured globally is used in agriculture as fertilizer. Because of that, farmers will be our first customers. Ammonia is also commonly used in many other sectors, as you can see here, but this presentation is focused on the agricultural market. For over 100 years, the industrial process used to produce ammonia has been hailed as one of the most important inventions of the 20th century. It saved the world from famine through the mass production of ammonia, which is used as fertilizer, called the Haber-Bosch system. It made it possible to produce ammonia in large quantities that could be transported to farms, giving us food security. The problem is that the Haber-Bosch method, still used in massive fossil fuel powered refineries, is one of the most emissions intensive manufacturing processes in the world. For every single metric ton of traditional or gray ammonia produced globally, almost 3 metric tons of greenhouse gases are emitted. Also, these refineries are centralized, with a small number of them providing all the ammonia used around the planet. The resulting ammonia needs to be transported vast distances from the point of production to the point of use. That supply chain is wildly unreliable. Farmers, for example, never know exactly when they will get their delivery, how much they will get, and how much they will have to pay. Ammonia is becoming unaffordable, and with the war in Ukraine, it is getting to be a lot worse. Here is what we call the ammonia paradox. It makes it clear why our technology is so needed. Ammonia used for fertilizer is essential for global food security. The traditional system used to produce ammonia creates huge carbon emissions, which contribute to climate change. Climate change threatens food security. It's a vicious cycle. And at the same time, the traditional supply chain is unstable, and the price has risen so much that many farmers are saying it is completely unaffordable. Well, before the terrible events in Ukraine, the inventors of our technology were thinking, what if we could produce ammonia without polluting? And what if we could solve the supply chain and price problems? And that's exactly what we've done. This slide shows how we do it. You can see that the containerized unit includes an electrolyzer to produce hydrogen from water, a nitrogen generator to produce the nitrogen from air, and a novel patent pending ammonia synthesis converter to produce ammonia from the nitrogen and hydrogen. Our initial intellectual property is centered around the converter. We filed for a provisional US patent last June and will be filing for a US non-provisional patent in just a few days. The new application covers additional IP that we've added as we've developed the system over the past year. Unlike traditional gray ammonia, our system uses a sustainable source of electricity such as solar, wind, or hydro. That's essential if you want to make green ammonia with the CO2 emissions. Beyond being carbon-free, our model is purposely decentralized. It eliminates the supply chain because the green ammonia is produced on-site where the user needs it. The systems can be scaled up or down depending on the end user's requirements. Validation is performed following standard. Our system has been designed. Sorry, I'm kind of out of sync here. My apologies. There we go. Here's what it looks like on a farm. You can see that the water and air go into the FuelPositive containerized production unit that is powered by sustainable electricity sources. In this case, some windmills and a solar array. The green ammonia produced using our system will then be stored on the farm to be used as needed. You can see some storage tanks behind a FuelPositive unit here. The farmer will use our green ammonia as fertilizer for their crops. It can also be used as fuel for tractors, grain drying, and other farm systems and equipment the farmer uses, including generators for backup and high power demand. If the farmer has a sustainable and stable electricity source on the farm, their supply of green and hydrous ammonia will be steady with no price fluctuations year after year, and that's the driving force behind our system. This level of supply chain and energy security is an absolute game changer for farmers, and we are receiving inquiries every single day from all over the world. I should point out that the first demonstration system will be fully validated before going to the farm. The first system slated for a farm in Manitoba, which runs off of a 100% sustainable grid. So they actually don't need any solar panels or windmills. It'll be producing 100% green ammonia. It's slated to be installed September or October. We've hit all of our milestones for production, and there's a system number 2 and number 3 coming right behind that. We do have pilot farmers already ready to go on that. When we say pilot farmers, these are pilot farmers who have committed to purchasing the units too. So it's a pre-order as well as a pilot test. Our system has been designed to make its operation simple despite the advanced technology we utilize. Customers will receive on-site training, but there will be little for them to do. That's because we've designed the system with over 145 remotely monitored points so that FuelPositive can monitor it, optimize it, and maintain it from our location, and use our machine learning and AI software to keep things running smoothly. We expect the life cycle of our systems to be several decades with periodic upgrades. For instance, we expect to do a first catalyst upgrade after a 15-year mark. The overall life cycle of the system is pushing over 40 years. And we'll continually advance technology. So due to its modular design and remote connectivity, each customer will be able to take advantage of new technologies as they become available. I should also point out that unlike a large refinery, our system can be started and stopped quickly. Downtime for things like upgrading a component will be minimal. And with our novel converter design, we can also vary the rate of the output of our system. We've worked hard to engineer and build a technological solution that works away in the background while dramatically improving the global environment and outcomes for our end users. This is our costing model slide. This is based on a case study from a farm in Manitoba. This slide shows you that the key point is the end user will be paying considerably less to produce our green ammonia compared to buying gray ammonia. So even if they aren't only driven by a need to reduce carbon emissions, they will want to use our system because of the price and practicality. When we developed this model, it was based on the farm in Manitoba in 2021. We set the average price of gray ammonia at $900 per ton. We all know that the price of ammonia now is over double that, and this is all based in Canadian dollars as well. Our cost to produce the same amount of green ammonia using our first demonstration system on the farmer's land would be $560 a ton. We also know that the amount will reduce over time as we build the system's efficiencies in the future. Keep in mind that the primary operating cost is the price of electricity to run the system, which varies from place to place and time to time. As we go on, the cost of solar electricity will continue to decrease, as will the cost of the ammonia production of our system. So you can see in 2022, we're roughly $560 Canadian per ton, compared to at the time we were pricing ammonia at $900. The other day I priced ammonia at over $2,000 a ton, and we're still at the $560. And as time goes by, price of solar electricity goes down, so the ROI on the ammonia goes up. There's another benefit to green ammonia. Because it is produced without emitting carbon dioxide, it's now being considered for uses that were never thought to be reasonable before, such as a fossil fuel replacement for internal combustion engines in the transportation industry, or in virtually any application where a fossil fuel is used today. Green ammonia is also considered for ammonia fuel cells, as we believe it makes much more sense than hydrogen in fuel cells, because an ammonia fuel cell delivers the energy contained in the ammonia without all of the expense and distribution problems associated with pure hydrogen. We're working on that. Green ammonia is also being considered for grid storage, and since ammonia contains more hydrogen by volume than pure hydrogen, and is much easier to store and transport, it's seen as an ideal carrier of hydrogen for the evolving hydrogen economy. All of this points to the fact that the ammonia industry is poised for a dramatic upward shift in demand and market size as a result of net new green ammonia applications. Approximately 200 million tons of traditional ammonia are produced every year around the world, with an annual market value of about $70 billion US, about 80% being used in farming, which will be our first area of focus. The existing gray ammonia market has been a commodity type market with compounded annual growth rates of about 5%. A number of recent projections about the market size for green ammonia because of these new applications suggest compounded annual growth rates over the next decade of 50% or more. Now let's talk carbon credits. We plan to generate significant carbon credits. The carbon credit revenue, although procedures and carbon schemes exist, we are working on an ammonia-specific protocol and policy to address this opportunity in a targeted manner. The revenue derived from carbon credits and emission reductions will fund future growth and investment in new carbon conscious technologies. It will also help to offset the price of our systems for our customers. Let's look at some numbers. Globally, producing 1 ton of green ammonia causes 2.87 tons of carbon emissions. Our initial demonstration system will produce just over 100 tons per year of carbon neutral green ammonia. So one system will save 287 tons of carbon emissions. Now let's set the value to that. We are using California as an example. California's current carbon credit rate is $29.98 per ton. You can see that one of our systems will then generate $8,604 a year in revenue for us. 100 systems will generate $860,000, and 1,000 systems will generate $8.6 million a year. The values assigned to carbon reductions differ depending on jurisdiction, but we think it is safe to say that we expect to generate a significant revenue from the carbon credits over and above the revenue that we bring from selling our systems. Just as we've all seen with Tesla, the potential is huge. Until the world is sufficiently decarbonized that carbon credits are no longer a thing, we think that might be in about 15 years. Not everything is about problems, solutions, market size, and cost models. Since we acquired the green ammonia intellectual property in March of 2021, we have been building the team to commercialize, sell, and service our systems. This is what we call a constellation of stars, because every person is a star in their own right, but we work together brilliantly according to our values. I didn't write this, and my picture's up there, so I'm not calling myself a star. Allow me to mention just a few quick notes. Ian Clifford's our CEO, purpose-driven leader who has raised over 75 million for the company. Myself, COO, I've got over 30 years in the high-tech automation and robotics industry. Dr. Ghassan Shihadi, who is our lead scientist, he's one of the co-inventors of our technologies. Shola Ashuru, a New York-based portfolio manager and founder of New Energy Fund 2. Andre Mack, an emissions reduction and carbon credit specialist with a global experience. Derek Boudreau, who has worked globally for John Deere for 27 years in sales, marketing, product engineering, product support, and operations management. Claudia Wagner-Riddle, a professor at University of Guelph, known for her research in greenhouse gas emissions and measuring carbon footprints. And Jean Milne, a business analyst who is leading our efforts to secure government grants. We also have Leith Deacon, an associate professor at University of Guelph with extensive rural community market research experience, and Francois Delos, our senior business and technology analyst who has over 25 years experience working with high-tech startups. We've certainly got the skills, experience, and know-how to make our company a success. Now to summarize, with the skills with our team, simplicity and practicality of our technology and decentralized model, we expect to make an impact in many vital emerging markets around the world, starting with agriculture, because we address climate change and many different levels, and because of our approach, simple makes sense. Solving the huge emissions problems associated with the production of fertilizer alone will have such a massive impact and a positive environmental effect globally. And when you add in the impact of green ammonia and can have in transportation, fuel cells, grid storage, and as a carrier of hydrogen, the potential is almost mind-boggling. We don't think we could be entering the market at a more relevant time because of the obvious effects of climate change on our lives and recent world events, from the COVID-19 pandemic and the Russian war in Ukraine that have shaken global supply chains to the core. The need for sustainable and decentralized has become so obvious and essential. We are financially solid. We have a brilliant team. Our IP is solid and expanding. We are about to take our demonstration system to the field. We have been designing all along for serial and assembly line manufacturing, and we'll be starting our manufacturing in 2023. It's just up to us to make sure that we're known and our solutions adopted around the world. We're communicating to stakeholders, governments, partners, shareholders, and potential investors and customers every day. Thank you for listening. We'd be happy to answer any more of your questions. Sorry? Yes, we have. So we started out with a benchtop lab system, and that gave us some initial set of numbers, and we made a larger prototype system, and that validated those initial numbers, and that allowed us to scale up to the demonstration system. So and on the demonstration system, we've already ran FATs on the hydrogen generator and a nitrogen generator, and the converters are just being put together right now. And we expect within about 6 weeks, we'll be running ammonia off of those.
How much power is needed for the on-site production?
So so in the United States, if you're running on 460 volts, it'll require a 220 amp supply. So it's important to note that the system runs on electricity. It doesn't make, it makes ammonia, and it doesn't make green ammonia unless you use a green sustainable energy source, right?
Part of the process that you go install.
Yes.
Figure, let's say, renewable.
Correct. So we'll evaluate the location because some places are blue, which can qualify for some carbon credits depending on the jurisdiction. But we'll evaluate it, and we can provide the full turnkey solution with the solar panels or the wind or whatever works best. Correct. Yeah. So one of the reasons why we're here is we're getting to know some of the other companies, because we obviously don't do biogas and we don't do solar. We don't do wind. So we're bringing in those partnerships to be able to do a turnkey system.
You start getting the biogas sources, and you have lots of energy generation options, you know, like a generator, small turbine, different things you can use, right?
Mhm.
So and when you're looking at that, and you call it the network, kind of going out to look at the best options, best places to sell, because of having renewable gas or like wind or whatever.
So that's what we've done. So we've looked at Manitoba being 100% green grid. So Manitoba is a no-brainer. It's 4 cents per kilowatt hour, which is one of the cheapest rates of electricity in North America. So we've targeted Manitoba just to begin with. And then the model for Manitoba transfers very well all along the US, the Corn Belt, right, the Midwest. So now you just have to look at the energy consumed. Now, one of the things with RRP is we create ammonia very efficiently. So the energy used, whether it's sustainable energy or non-sustainable energy, it's lower than what we're seeing out there in the market right now. But what we're seeing in the market is only what's publicized. We don't really know what's coming around the corner. Everybody's working on more efficient methods. So we continue to make our system more efficient. We're working on hydrolyzer technologies to be able to make hydrogen a lot faster and more efficient. And that's a big part of it, is the hydrogen. And one of the things with our current system, which we assisted in the design, but we didn't build it ourselves, we subcontracted it out, is the purity of the hydrogen is very pure. So what that does is it extends the life of the system, because the membranes last a lot longer. You don't contaminate the catalysts, that sort of thing. So when we're comparing it to the other systems that we've seen out there that we know of, that's one of the differentiators. So when people say to us, how can it last so long, and you're not going to have to change catalyst till 15 years, this is one of the reasons why. Right.
You're offering own operate or leasing?
Yeah, that's a great question. That's why we brought in Derek Boudreau. So he worked with John Deere for over 35 years all over the world. So he's very familiar with the purchase models. And when we're dealing with agriculture, he's used to building out these sales plans to sell combines and large tractors and large equipments for agriculture. So we do have some different options for the farmers. So we've got the outright purchases. We've got like lease options. We've got some other where we're sharing risk. You've got some farmers think that the price of ammonia is going to come way down. We're not so sure that it's going to happen. So what we do is we build like a comfortable model to work with. And then there's currently there's a lot of government subsidies that we expect to come down the pipe, which I wouldn't call them subsidies, but there's going to be financial support for the farmers, because let's say a province like Manitoba is recognizing that the food shortage is not going to be solved by not putting fertilizer down. Right. So they want to make sure that there's fertilizer machines and supply in the pipe coming down. So, and Manitoba I think they're probably ahead of a lot of the other areas, but it's a good model that I think other areas will adopt. And Europe is so far ahead of us in this, and in Europe is just calling us on a day-to-day basis. So.
Well, it seems
Mhm. Mhm. Right. One thing to remember that this is it's a containerized system to be distributed. So if you're thinking biogas, you're usually looking at a small area like a municipality that's drawing from that biogas plant. What we're looking at is these systems would go out into small farms. So we would evaluate that and see where that's coming from. But there's no reason why these are scalable. And the way they're built is there's a control head. So a lot of the cost, the CapEx comes around all the instrumentation and the control. So there's a control head. The control head could be located in one location, and you can put the units, the generation units, in multiple locations, right? So one farmer could buy one system with a control head and then distribute those systems out and stack them up. So they could go from doing 100 tons to 1,000 tons a year fairly quickly with the same control head. So it's very feasible that they could scale them up. But 100 tons a year is good for a farm that's roughly 1,200 acres. This farm in Manitoba is 11,000 acres. So his plan is to initially purchase the first unit, get that unit up and running, apply it onto his fields next year, and then start scaling up. So he would need 6 systems to do all the ammonia that he needs.
You can see more increasing focus on that as well, the CI score of carbohydrate itself. So
Exactly. Right. Right. I think we're over time. Thanks very much, everyone. I appreciate your time.